Welcome students. In this session of C++, I am going to explain you about static data members and static member functions. Okay, so let me begin with a simple example. With the example itself, I will be explaining you what a static data member is. Then later on we'll move on with the static member function. Okay, suppose we have a class, we have an example. Suppose we have a class, say test, to which I have two data members, private int a and b. Okay, now for this I have a constructor in public, say test x int y. Okay, let me initialize this data members with x, a as x and b with y. Okay, now these are the private data members a and b, and also let me have one default constructor. Okay, so that it does not cause any problem while creating objects without arguments. Okay, now this is a class test. Okay, and into which when I have two private members a and b, then as with respect to C++ classes and objects, as you go on creating objects of type test, say like test t1 comma t2. Okay, over here t1 will have its own a and b, t2 will have its own a and b. Okay, this is the concept of object oriented programming. Okay, wherein t1 is encapsulating the private data member and the member functions into one object or one runtime entity called t1 object, and t2 does the same. Fine. Now t1 has its own a and b, t2 have its own a and b, the normal approach. Okay, in the normal case. Okay, now when I declare one of the variable, okay, let one of the variable be declared as static int. Okay, static int a, then b, let it be declared as just a normal int. Fine. So now let us see what would be the scenario, or what would be the effect of making a private data member or a data member of a class to be as static. Okay, now as per the definition of static data member, it tells the compiler that only one copy, okay, of this data member exists. Okay, that would be shared by all the objects that you go on creating. Okay, if this would have not been a static, the variable a, then every object which you go on creating would have a for itself. Okay, but in this case, when I declare a variable data member to be a static, it will each object will not have their own a. Instead, there will be a single copy. Okay, it tells the compiler that there will be a single copy of a that would be shared among the objects. Okay, so that effect I will be showing you with this example. Suppose I create an object of type test t1. Okay, and for this I will be passing the arguments 10 and 20. Fine. Now let me have one member function to print the values of the variables. So void print underscore a b. Cout a equals a, cout b equals give /n/b. mentioned over here, cout. Okay, so we have a member function which prints the values of a and b for the objects, okay, that are getting created. Okay, now first I instantiate the object t1. Okay, I instantiate the object t1 with 10 and 20. Okay, so 10 gets assigned to a, 20 gets assigned to b. Fine. So let me call print underscore ab. Fine. So due to which a the value 10 gets printed, for b the value 20 gets printed. Okay, now suppose I create another object, test t2. Okay, with the value say 50 or 100. Okay, now you might be under impression that as in the normal variable case, okay, 50 gets assigned to the variable a of t2 and 100 gets assigned to the variable b of t2, but in this case a is not a normal declaration, it is declared as static. Okay, so in this case this a is not associated with any of the object, it is been shared among the objects. Okay, so now over here whatever new value is given by the object t2, that is assigned to a. Okay, and the older value which was assigned by t1, that is 10, is overwritten. Okay, so the effect I'll just show you. Now let me just first print t2 dot print underscore ab. Okay, now you print with t1 object. Okay, so over here, or else you can do what is, you can just strike off this part so that you can understand, or else I'll do what, give some interactive statement, say out object t1 created with values. Okay, next I give the same statement for t2 object t2 created. Okay, fine. Now over here let me just give this statement, yeah, no problem. Now after this I'll just once again give a cout statement saying modified object t1 exists with values. Okay, now you just see, I'll just save this as static.cpp. Okay, now let me compile this code. G++. Okay, now one more specialty of static data member is, in this case I'm just declaring it. Okay, in class test I'm just declaring it. Okay, but just making a declaration will not provide a memory location for static data member. Okay, so you need to provide a definition for it somewhere outside the class. So the definition goes like this: it's database int and it belongs to the class test, scope resolution operator and a. Okay, by default the value of a is set to 0 by the compiler. Okay, the initial value for the static data member is 0. Fine, and one specialty of the static data member is, by declaration memory is not allocated, so a definition somewhere outside the class should be provided. Okay, so this is the definition for the static data member A. Okay, so over here A exists but is shared among the objects that you go on creating. Okay, T1 object, T2 object share the variable A. Okay, so when T1 gives the value 10, 10 gets assigned to A, and T2 gives the value 50, 50 gets overwritten on the older value. Okay, so the older value 10 is no more existing. Okay, that you can see at the output. First T1 object got created, then T2, then you just see the output. See, object T1 created, it gave the value for A as 10 and B as 20. Then object T2 got created, gave the value A as 50, B as 100. Now object T1 exists with values what? See, the older value is no more existing. Now whatever new value was, so for this, by this you can understand that the variable A, which is having the static nature, is shared among the objects rather than the objects having their own copies. The object is shared among the objects. The variable, the static data member is shared among the objects. Okay, but here B is a normal data member. Okay, which every object possesses a copy of it. Okay, so every object will be having their own B in this case, but A is shared. Okay, that's the nature of static data member. I hope you all have understood the concept.